Welcome to myprojectbazaar.com. Let we discuss about the process oriented image foresting transform segmentation by seed completion. Let me see the abstract of the process. In this process, the segmentation process is employed to identify the lung regions in the images. Segmentation process helps to identify the specific regions in images. The segmented regions were used for computer vision for further process. The required regions were previously saved and trained by the systems. This process is the registration of the required portions. The registration process helps in preserving the shapes of the required object in the input images. We predefinedly save the left and the right lung nodal positions by manually cropping them in the system. After that, the mean value of the images were calculated and they were saved. The mean value of the systems were compared in order to identify the exact shape of the input images. After the identification of the exact shape, the particular portion is applied to the input images. Both the left and the right lung nodules were segmented and the segmented portions were compared with the original images in order to produce the contours extracted from the images. The feature values extracted from the images were compared and based on that the selected regions were identified. After the selection of the exact contours for the input images, the regions were segmented from the original image. The proposed system overcomes the disadvantages of the graph-based approaches for identification of specific shapes in the images. The performances of the process is measured by comparing the segmented pixels with the ground truth in terms of accuracy, sensitivity and specificity of the process. Let me see the flow of the process. The input images were obtained. In our process, we use lung images and the lung lobes were segmented as a result. So first the input images were taken and they were basically pre-processed with the help of basic operations like gray conversion, resizing and basic filtering using median filter. After that, the features were extracted from the input images. In the same manner, for all the images that we have given in the datasets, the trained features were extracted and those values were saved. Similarly, for each images that is in the dataset, the shapes of the both right and the left lobes were manually segmented and they were also saved. So this process is the training process. After that, the distance between the test image features and the trained features were calculated. So if the distance is minimum means, then the shape corresponding to that particular ID is obtained. Else the distance is compared with the next trained features. So this process goes on in iteration. So at which step the minimum value is achieved, the corresponding image shapes were retrieved from the saved databases. So in that both the left and the right lung lobes where shapes were extracted. After that, the extracted low regions were applied to the original images and the particular regions were segmented. So for this process, the regions which contains that particular portions were selected were obtained from the original images and they were mapped on the original images in the form of black and white representations. After that, the regions after that the contours were extracted based on growing the outer boundary around the detected regions. So after the extraction of the contour, each loops were given some different representations as the segmentation processes, and finally the overall performances of the process is measured in terms of performance metrics like accuracy, sensitivity, and specificity of the process. Let me see the running procedure of the process. If you want to run the code, select the file main.m, which is located in the source code folder. Right click it and click on run file. You will get the user interface for the execution of the process. The mat files here were, so this is the user interface. So the POSR is the right left loop regions, and POSL is the left loop regions, and this is the data means the feature values, and the same means is the mean value of the images that were previously saved. So this is the user interface. This contains the buttons and the display accesses for the execution of the process. Select any one of the input images which is present in the dataset. So we select any one of the input images. After that, the images will be displayed in this axis. This is the test image. After the pre-processing step is done, which includes the resizing operation, filtering operation, and the gray conversion operation. After the pre-processing step, we can see the overall image is smoothened. Next, the regions were selected from the input images. So here this sheet points represents the x and y coordinates of the right and the left lung lobes that is matching to this input image. After that, the overall outer boundary of the images were detected. After this detection, as we can see, the images were outlined as the overall detected regions, and finally the particular lung regions were segmented in the images. So this is the detected lung portion, and this is mapped with the original image to extract the detected lung lobes. After that, the detected lung lobes were represented in different representations. Thus, we have segmented the lung lobes. After this, the performance of the processes were measured in terms of accuracy and the overall error rate of the process. Thus, we have segmented the lung lobes from the input images, which is based on the registration process in which we have previously saved the shape of the input images, and the matching shape is applied to the original images, extracting the required objects from the images. Thank you.